Good day, grade 11s. I trust that you are doing well. Today's lesson focuses on trigonometry. So I have a question that is an extract from a previous question paper. So let's get into it. So 3.1 goes as follows. We are given a point P on the Cartesian plane such that the angle POX is alpha. So for the first question, 3.1.1, they want us to calculate the length of OP. So let's identify that length real quick. So they are referring to OP, this line. We need to find the length of this line. We can find the length of that line by making use of these coordinates. -8 simply tells us that point P is exactly -8 units from the origin. So this here is -8, -8, and 15 is telling us that it's 15 units above. So we have a right triangle here. We can make use of Pythagoras theorem. So let's just write that down. So we know Pythagoras theorem states that the square of the hypotenuse, PO squared, is equals to the sum of the squares of the other two sides. Let me just notate this as 15 here. So that is PO squared is equals to x squared plus y squared, where x and y represents the coordinates, x and y coordinates respectively. So this here is because of Pythagoras theorem. So now we can substitute x squared would be -8 squared plus y squared is 15 squared. So -8 squared is 64 and 15 squared is 225, which gives us 289. So all this is equals to PO squared, but we're not looking for PO squared, we're looking for PO. So we can take the square root on both sides. So square and square root cancels. So therefore PO should be equals to square root of 289 is 17. So we can just note PO, the length of PO on the diagram, to be 17. So now we have, with respect to the angle alpha, we have the adjacent side. And just note this, we have the opposite side, and we have the hypotenuse. So now we can apply our trig ratios. So let's check 3.1.2. 3.1.2 says determine without using a calculator the value of tan alpha. So let's have a look at tan alpha. By definition, tan alpha would be opposite with respect to the alpha, the angle alpha. It would be the opposite side over the adjacent side. So it would look something like this. Tan of alpha is equals to the opposite over the adjacent side, and the opposite is 15 over the adjacent, which is -8. So moving on to the next question, they want us to find they want us to determine this expression without using a calculator. So let's just write it down real quick. So by inspection, we can use reduction formula here. And for the second one, we can use negative angle formula. So we can firstly, what we can do is we can reduce the terms given highlighted in green. So this can be rewritten as 17 times, now sine of 180 minus alpha. We know that sine, if we write down our cast, we can see that sine, if we mark the places where it's marked is where sine is positive. So sine 180 minus alpha would mean that we are in the second quadrant and sine is positive. So this can be written as sine alpha minus, according to negative angle formula, cos negative alpha is the same as cos of alpha over 8. So now we can just substitute. So this can be written as, I'm just going to go down here. I'm going to continue down here. So this is sine alpha, according to our trig ratios, is opposite over hypotenuse, which is opposite is 15 over 17 minus, and cos alpha would be adjacent, which is negative 8 over hypotenuse, which is 17 divided by 8. So this can be written as, if we simplify this, 17 and 17 cancel, so we're left with 15, and minus 8 over 17 times 1 over 8. So this and this cancels out. So this can be written as 15 minus and minus is plus 1 over 17. And if you reduce all of this, you should get 256 over 17. And the final answer says, the final question rather says, calculate the size of alpha, round off to 1 decimal digit. So in other words, round off to 1 decimal place. So let's have a look. We need to find the angle. So we can make use of the trig ratios. Particularly, we can focus on, we found 10 alpha. We found 10 alpha earlier on to be 15 over negative 8. So we can use that trig ratio to find the angle alpha. So let's do that. So we can say 10 alpha is equals to 15 over negative 8. This implies that alpha should be equals to 10 inverse 15 over negative 8. And this gives us negative 61,927, correct to 3 decimal places, but from the diagram we can see that alpha over here is an obtuse angle and is a positive angle because it's measured counterclockwise. So it means this given angle then becomes a reference angle. But we know tangent is periodic for every 180 degrees. So the true size of alpha would be, when we say periodic, we say that it repeats itself after every 180 degrees. So that would be 180 plus minus 61,927 degrees, which gives us 118,073. But the question wanted us to round off to the nearest decimal digit, so we can round that off correct to 1 decimal place. It should give us 118,1 degrees. Thank you for watching. See you in the next one.